Hello. This is our third lectures about critical look at existing software engineering problem and solutions. I'm here very specific because again, we have a lot of critical look at every aspect of software engineering. And start with this because this is very important, by the way, because we don't know how to really define and actually abstract the requirement for any software applications. And I'm going to explain that completely, by the way. And solutions, we just do a solution. So that's why it's very critical. And the questions here would say, is any domain knowledge, including software engineering, an art, science, and engineering? This is actually, we need to find the answer to these questions and try to find a solution for it. And this was the third part we're talking about. So this is toward the new horizons, and this is related to unifying software engineering. So as you can see, this is 3 based about me with a lot of links. Most of them works, but again, some of them doesn't work to some reasons I'm going to explain later. This is, I'm not gonna just talk about it, go through it very quickly, and come to the objectives here. I start with a conclusion and end up with a final conclusion. Then what we means by, this is gonna talk about with this question we're talking about. Then we explain it, and we started talking about many different solutions for what we have as a dilemma, by the way. Anyhow, let's go into the lectures. Conclusion here, the question we'll start with, and this is, remember, 3 parts, the third part of the critical look at software engineering, is in domain knowledge, including software engineering, an art, a science, and engineering. This is, again, it is very strange to start with a presentation with a conclusion. The answer is no, definite no. So any word or any domain knowledge is an art, science, and engineering. This is from the font there, where the word is noun and noun phrase, and the domain is any discipline or any field of knowledge. This is, again, you must know that. And we're going to show you this by doing what we're doing here. There are certain rules here we have to apply. The apply here of this word is very important. So any word or domain contain morals and ethics. 60%. If moral and ethics not exist, this is a disaster. It's considered 60%. Are you talking about unified software engineering? Should have morals and ethics? Yes. There is nothing could really be any field of knowledge without moral and ethics. And you will find out we have in San Jose State University 1 credit, separate credit, and actually sometimes I don't even pay attention to teach moral and ethics in the field of engineering, including software engineering. Knowledge and cultures, so this is very important, 30%. Let me explain that, by the way. The knowledge of software engineering, I claim there is no knowledge because, unfortunately, we build an instance. And for examples, you manufacture instance of software applications and software systems and software design, whatever. This is kind of really, and you get charged a lot of money. It has no resale value, none. So when you share the computer, it has a lot of software on it, costs a lot of money. When you try to sell the computer, software means nothing. And this knowledge, because again, if it has knowledge into it, fantastic. This is actually, you would really bring money into it, by the way, and you take money out of it. 3%. Working applications, 10%. I'm going to explain that through the life cycles, what we do in software engineering, by the way. This is very important. Look at it from the cycle, the life cycles of software engineering must have, as I told you, morals and knowledge and culture too. Because again, the software made in one country is not appropriate for other country, believe it or not. Because again, this is very important to have culture into it too, by the way. Many people forced to really use software made in America because it's the only way to really do their business. It doesn't fit with the culture there. And I have a lot of examples of this. Anyhow, look at this. This is actually, remember this. This is one word within the domain, has morals, knowledge, and applications. This is kind of really, but the percent is 60%, 30%, 10%. And I guarantee it, all the existing software systems and all the existing software engineering courses and knowledge and everything doesn't have any ethics, period. This is to tell you the truth. So now this is again, sorry, I'm just going through very quickly here. I don't know what did I do here. This is again, as I said, we'll go into the second one. Rule 2, any word or domain is an art and science and engineering. Where rule 1 match rule 2. This is again, you have to really consider, this is the 3 category of the first there, morals, knowledge, and applications. Now, this is again another rule. Rule 3, which is very important. Rule 3 is actually art of abstraction, software stability models, achieve a word or domain knowledge, and unified stable linguistic engineering. Those 3 here considered to be the art and science and engineering, where rule 3 match the rule 1 and 2. This is, I have to be dependent on each other, by the way. So this is again, explanation. The word knowledge has more than 50 discoveries. Remember, I'm talking words here, not concepts. This is very important. 300 innovations, 100 cognitive knowledge per word, noun or phrase, or within the natural language dictionary. Then addition, word knowledge has more than 10 significant outcome discoveries and contributions to add it to the human knowledge. And there is a few of them. Those discovered innovations, the cognitive knowledge exists more than 30 field of knowledge as a research, as a base for research. This is again quite a bit of, and this would be documented in volume 1 to volume 5 in Unified Words. Research direction, the discoveries and the innovations. This is because you remember the word is a milestone or maybe the cornerstone, for in any field of knowledge. Remember, not concepts. I'm going to explain that very clearly, by the way. And I did that before. So, this is a book of art of abstraction to show you we have many different ways for how to abstract many different things. In existing software, noun or verb, check for the nouns. This is disaster. This is nonsense. This is baby stuff. You cannot build software by checking for the nouns. In written document has nothing to do with requirements. This is again, I'm certain what I say here. So this is again, this is considered to be the art of abstraction. We don't do art and abstraction software engineering. No way. This book has several and many different algorithms and processes for show you how to abstract different things. different 50 discoveries about any word. Now, every field of knowledge depends on abstraction. We could do better on abstraction process and the type of abstraction because it is mainly what we do on tangibility and ignore other essential abstraction. That's what we're building everything on. This is a disaster. And this is actually, that's why software, all the software I learned before is gone. Because again, those abstraction, as I told you, in tangibles, changeables, and we ignore the essential abstraction. Really important to remember this. That's why this is very important to build a stable and unified system. We'll start with abstraction. That's why when you do modeling and you start building the software, you have to do those abstraction. Nouns within the statement given to you as a requirement, this is a disaster. By the way, I have a process for how to solve this problem too with existing software. I'm really trying to provide what I can. We're going to talk about this a lot, by the way. So it's still an art of abstraction too. Art of abstraction will be used to utilize and utilized in any applications. This is in system development. As a unique system, every word have more than 50 discoveries. We have to abstract those. Here are some of the examples. Unified goal. For example, there's a rule for this. The word has classification, as I told you, 2 types of words, enduring business themes and business objects. The third type is actually concepts. The one we'll use for applicability, for application. So at least you concentrate on this. Can I do this for concepts? Yes, but there's no value. I waste my time on things no value, but I can do it. You see? So ultimate goal impact shows, everything we do and every project we do has many different goals. This is again, you talk about a certain project for education, for swimming, for soccer, but again, this is actually the base for project exists, and this is actually has to be that the ultimate goal has a positive impacts. The rest have negative impacts. Then unified function requirement, we don't have function requirement. Don't believe they said computer engineering, this is requirement engineering, this is nonsense. This is completely crap, basically. So, non-function requirement, that's introduced 12 new discoveries, because again, through this non-function requirement, it has to be executable too. We don't know how to do it. You will discover 12 important factors for evaluation, assessment, measures, branding, unified definitions or defined of everything you do. This is a lot of stuff you can do, by the way. You discover a positive energy within your work, and measurement, branding, and other things. Unified ultimate design. That's why we do this, because again, there is too many design. So one design, it doesn't mean you did a very good job. So you have to really define the ultimate design for any problem and any system you build. Unified architecture and demand. Yes, we build an architecture. This is very valuable. So I could use it for as many applications as I can. Just a unified architecture. I cannot build an architecture for any systems. Keep try this and keep. This is no way. That's why we're talking about maintenance and upgrades and maintenance contract. This is crazy. This is actually going to really puzzle. It's not appropriate, basically. So, actor and legal parties and roles within the system and out the system. For example, we build roles into In current system, we don't have anything for legal parties. And actors is only two types, hardware and human. This is ridiculous. Doesn't make any sense. You'll watch, I have my own mail with a lot of heuristics everywhere. Then we don't have legal parties. I included legal party within your mail. And now rules has to be within the system and outside the system, the users. Because again, we build the system, we don't really know who the user is. That's why we fail. Another failure of software, existing software. This is very important. Now, this is actually to tell you, this I could go on. So this is again, this is the art of abstraction, unification, discoveries with unlimited advantage. Is advantage understanding, appreciate our natural language. Because this is the base. This is the system of a system. We don't understand our natural language. Therefore, because if I discover 50 discovery per word, this is actually, I'm talking about now is now. I didn't get into other type of words at all, by the way. The future of technology depends on those discoveries and unification of domain analysis of any field knowledge. We need to have a unification of that because we don't really have to reinvent the wheels. This is impossible. And we have to build the same system everywhere. Doesn't make any sense. Know how to generate stable and unified requirements and design for any system you imagine. Unfortunately, we don't really have that, period. So knowledge unification. We need to unify the knowledge. For example, the accounting. It's in every field of knowledge. Do you know it's the same foundation, the same requirement, the same non-functional requirements, the same ultimate design, and you could use it everywhere. You could use it in finance, you could use it in computer, you could use it in entertainment, you could use it with all the relationship you have with too many different people. You have too many accounts, and you really have to be very reliable on those accounts. And very honest too, by the way. So you have to build a system. It allows you, need to really have an engine, build on top of it as many applications you want in your mind, in your active life, in your business. There is no need for really having duplicate tools about too many different things in accounting. This is a principle is already been set up. This is again when we have a lot of relationship, which is actually a lot of dealing and wheeling as an account with money, with people, with God, with everything around you. This is an accounting, by the way. So this is again, and this is accountability is very important. So number 4, limit and control maintenance problem. We're not going to go forever for this maintenance problem. No. A company in software, they do 10% of development and 90% of maintenance. That's why in NIST, NIST agency, they indicate maintenance is 20% of the cost of the software. This is insane. Maintenance is more than 2,000% of developing software, which is crazy. This is actually cost a lot of money and cost the community and the people a lot of money too. Because, for example, the iPhone is an example I usually take and tell you, it's the same iPhone since the start. They change a few things, they make it look beautiful, you change the camera, stuff like that, they charge the same amount. It doesn't make any sense. This is crazy. This is one company gets so fat and so big, and we're all getting poor. This is not appropriate, by the way. Anyhow, We need to go on and build other systems. We actually, the software development, as you can see it now, it's a pond. But we have an ocean, man. We have an ocean, man, in everywhere. We can build a lot of software to help humanity everywhere, in every aspect of life. So generate better methodology for developing unified and stable system. All the methodology exists doesn't have anything to do with that. Stop reinventing the wheels. Develop self-management, manageable, self-adaptable, self-executable, self-configurable systems, and with limited applicability and reuse. This is very important thing there. They claim it an existing system. This is nonsense. Don't believe that. I've been in software system experience and actually academic in many, many years. See, this is again very important for you to. If somebody told you the system is self-managed, they fool you. Even the word reliability there, don't forget it. Even scalability, forget it. They lie to you, by the way. This is a current software development models. This is actually concurrent software. One model is actually called the SSM, software stability models. And this is another base book, which is actually, this is software stability models. This is a collection of many different articles and responses and applications and show you how to utilize it in this specific volume too. So this is kind of really tell you. So, and this of course, this would be engineering. You start with this methodology, it is actually going to use it every day. In every aspect, what you're doing. Guaranteed. There is no, there's no separation of this. It's actually to go from requirement into design, expand. You find the promise space, then you go into the ultimate design, into the, then the architectures. Then implementation would be very simple. During this, there is no testing after that. No, you have testing with requirements. This is very important. Then you have testing with ultimate design. Coding will really be tested that way. It's not going to be a problem, by the way. There is no, I would really not lie to you if I tell you zero maintenance. You might get really a few human errors, which is very simple. It's not that much, by the way. This prevent human errors too, by the way. So this is actually to show you. Then we have the part of engineering here, which is actually, this is the SSM, can use to build system in any domain. There is no specific domain. There is every aspect there we do. There is no many different architectures. This is crazy. We have too many different architectures. We have really, each one of them has a lot of problems. As a scientist, I could map one to another, but again, they all fail completely. They all have disadvantage. This is really bad. This is again, when I teach architectures, there is too many of them. Service-oriented architectures, aspect-oriented architecture. Keep going. This is really, it doesn't make any sense. So, it's actually promotes a way to building software that is not tied to a specific domain or application context. When you build it, it becomes really every component is reusable. But you use it in any other domain, by the way. So the method employed designing software using SSM, software stability model methods, aid and advance our understanding to how to do requirement analysis that is long lived and hit rights at what is being aimed. No question about this. So the project would be advanced in the field of software engineering, benefit knowledge engineering in general, and software stability model. Words hold the many engineering disciplines, not just software. This is very important for you to know. So this is again, linguistic engineering is a science. Look at that programming, for examples. And everything we do in requirements design, this is a linguistic too, by the way. They call it linguistic computing. They don't know what linguistic engineering is. And linguistic science is, in my opinion, because again, you have to understand the engineering part of it. So the science has to be very important with what I do, unification. So it's a linguistic engineering is a rapid development field in research. No question about that. These people actually create a lot for research. Some of them, they don't make any sense. Some of them is very good. But again, I'm really looking for excellency. A strong background in language technology and linguistic engineering is precise in manipulating large data set. Linguistic engineer has knowledge of language technology, is used to computer application, including search engines, all uses of language technology in computer application, and all of the possible forms of applied linguistics, who can be captivated by natural language unification. That's what I'm coming in. And stability modeling from engineering and computational perspectives, and the study of appropriate engineering approach to linguistic questions. You ever thought about that? This is very important. So let me see what we have there to just show you. Natural language is appropriately considered the system of all systems. As such, to examine every word, known word, noun, or noun phrase. And actually, we have our classification here is actually EBTs and BOs. They apply to noun and noun phrases. Our noun phrase would be an architecture. They're all patterns, by the way. So as unified and stable patterns with as functional and non-functional requirement and ultimate design. This is very, very important. Every word has one individual responsibility. In any given scenario, there is no any CRC card, collaboration responsibility, a class collaboration responsibilities. There is not such a thing. One responsibility per scenario. And this is very important for you to know. Can be uniquely defined by the functional and non-functional requirement and unified stable patterns by employing unified approach. Postulate that any word can be defined such as a definition of adequate, complete for use in any field of knowledge. That thing I mentioned about the CRC card, which is actually, this is a new methodology by itself. And actually unified too, by the way. I will describe this because this is part of what we build. We have to sit down and define a CRC card for each word, not concept. Concept doesn't have any knowledge, by the way. Every concept has their own knowledge, belong to this, belong to that, And the war going on between software engineers. What the form of CRC card? Class, collaboration, and responsibilities. I have a unique one. I have it class, responsibility, and collaborations. Not responsibilities. This is just crazy. There is no this is actually what we call polymorphism in data, in operations, The club had to be polymorphic. The data has to be this when you have multiple responsibility, duplicates going to be everywhere. It's not going to be unique anymore. So this is kind to show you what's going on. My unified linguistic engineering has theoretical applied components. Theoretical linguistic engineering focus on the issue of cognitive science. Applied linguistic engineering focus on practical understanding of any of a word and word modeling in putting human language into use precisely in any field of knowledge. Look at this. What we're going through here, at least you would know, programming language would develop thousands of them, thousands, maybe 3 or more, 35,000 languages. We're going to go back to the natural language. We have to build system can be speaking the language we speak. That's why it has to be depends on what I'm doing too, by the way. Because again, we don't want to create the same ambiguities and problem in our speech and our development and our use and all stuff like that, by the way. So we have the vision to generate common and unified stable patterns language. A knowledge map, for example, this would be for domain analysis of subject, domain, or words, anything. Knowledge map for anything in the language, by the way. And we're going to do this for everything in the language, but we do it now for subject, nouns, and words. This is nouns to be applied to all fields of knowledge. In addition, linguistic engineering will lead to advancement, enhancement of other aspects of linguistics. Believe it or not. Have a lot of research in this area. This is the science. Language has 7 domains, 7 fields of the, this is amazing. This is, again, you're talking about very huge. And those 7 fields, we have generated many different words and different volumes we're working on for a certain technology, for example. So we're going to talk about this when we talk about, the development, such as, 5 volume books would be unified word, 3 source researches from everywhere. This is a book by itself. The source for research for this word. So unified word versus its concepts. There's close to 300 or more differences between unified words and concepts. If you know this definition, you don't use concepts. You don't do conceptualization. This is crazy. The unified word discoveries art, science, and engineering. They're all encapsulated in the domain. They're all encapsulated in the word. We're going to show this also, by the way, by writing these books. Those discovery, the art of them. This is, again, for example, the word has a new look at philosophy, psychology, and social life, science. And this is, again, engineering to apply it and use it in many different engineering fields. The same use. So if we have word in all engineering, it's going to be the same requirements, function, non-function, and ultimate design. You take it and build on top of it right away. They're all reusable. So this is, again, something you must know. This is, again, is any domain knowledge, including software engineering and art, science, and engineering? Yes. We have to really look at this knowledge in everywhere. Using what I'm really proposing you to use. It's very important for you to do that. Otherwise, you could get out of business very easy, by the way. And we stop, our software engineering is stopped In fact, every university teach different kind of software engineering, which is actually, this is nuts. They teach them programming, basically. There is no engineering there, which is very sad. Software engineering, you cannot build anything without software anymore. And if software is actually wrecked and actually have problems, your system gonna have a lot of problems. Period. You could build the perfect system, software will come and screw it up. Completely. There is no system I know unless you have many flaws in it by now and many disastrous issue. And actually software is still money too by now. Show you this in the application also. The questions is, I have a lot of questions next lectures about this. We're gonna include a lot of questions to discuss and ask to really you to reply and actually communicate with me. I'm willing to do this live, and I'm planning to build a lot of stuff live in now. Thank you for listening to me. I hope you like the lectures, and I appreciate it. You have a good day.